Hey, thanks for coming, everybody. Especially in the afternoon on a Thursday. I know I didn't want to get out of bed this morning, and I'm somewhere around the point of actually losing my voice. We'll see how far I go through the session. I think they're going to take bets in the back to see if I make it the whole way or not. So my name's Everett Dolgner. I'm in the storage BD team at AWS. And today we're going to talk about the tools that we have available at AWS to allow you to move data sets into the cloud. Maybe. There we go. So I'm sure that you've probably seen this slide before. If you've been to one of our storage sessions, this is sort of the AWS ecosystem. Our block offerings, our file offerings, our object offerings, and all of those things are fantastic. But if you have data locked up inside of your data center, inside of enterprise storage or NAS filers, or even just inside of servers, you need a way to get it into AWS and in a format that's usable and in a way that works with the applications that you have today. So this is what we're going to be talking about during this session. We're going to talk about the Snow Family, EFS file sync, which is something new that we launched last week. We'll talk about S3 transfer acceleration, and then we'll also talk about our Storage Gateway products and the way that Storage Gateway can help you build out a hybrid environment between your data center and AWS. So we're going to start with the Snow Family. Was anybody at reInvent last year in the keynote when we announced Snowmobile and drove the semi out into the conference room? So we've got Snowball that we've had for several years now, Snowball Edge that we also announced last year, and at the end, the Snowmobile. So everything from tens of petabytes in a single container all the way up to, or tens of terabytes, I'm sorry, all the way up to 100 petabytes in a single container to be able to do batch moves of data. So with the original Snowball, this is 80 terabytes of capacity, 10 gigabits of networking. It'll take an 8.5G impact. I've actually traveled with one before and checked it as luggage. And when I've done presentations and I bring it out, I'll usually drop it on stage and sometimes kick it off the stage to sort of show the durability. And no one has ever been as impressed as they were when I've said, hey, I checked it as luggage and we plugged it in this morning and the thing works just fine. So that seems to be kind of the bar is can you baggage check it and have it actually still read and write data and turn on? You absolutely can with the Snowballs. We do have these out on the expo floor. One of the very popular things to do with the Snowball at reInvent or at our summits is to take a selfie. You know, it's a gray plastic case, but people love to take selfies with the Snowballs. So if you want to, they're out there, and I know that the Snowball team loves to see those. So the Snowball is a way to physically move data without having to send it over the WAN. And that's one of the issues if you have a large data set, or maybe you don't have a lot of bandwidth, or you have inconsistent bandwidth. It can be very difficult to move data out of your data center and put it up into AWS. And Snowball helps solve that problem. It's also a way to get data back out. So you can use it to put data in, to populate S3 or Glacier, or put a data set into AWS. And you can use it to get data back out as well. So with the original Snowball, 80 terabytes, 10 gigabit of network, you get it, you've loaded up full of data. There's a client that you load. Everything is encrypted end to end. So all data that lands on the Snowball is encrypted, and the key never travels with the device. So you maintain the key separately. It's in the AWS console. There's a code that you have to use to unlock it. Then you can start writing data to it using the key. Everything is encrypted. So should someone get a hold of it and try to do some bad things to it as it's in flight, everything has been encrypted. It's also tamper evident. It's not tamper proof, because if somebody gets it, they could do some pretty bad things to it. But if they were to try to access it and then continue it through the shipping process, we would be able to tell. We also have TPM chip on the motherboard, so we verify the OS every time it boots up. We can verify the BIOS, and we can make sure that it hasn't been tampered with physically or electronically. This is the Snowball Edge. We announced this last year. 100 terabytes of local storage. This has compute, the equivalent of an M4 4 extra large. And as well, it has 10 gigabit, 25 gigabit, and 40 gigabit networking. So this is for larger workloads where you have more data that you need to move in one shot, Or you want to do some type of processing on the data before you send it into AWS. So you could be loading it up with data. Maybe you want to tag files. You want to transcode. You want to make some type of change to the data before it gets moved into an S3 bucket. You can do that with the Snowball Edge. Some of the key features on the Snowball Edge specifically, there is an S3 compatible endpoint. So you get an S3 API that you can connect an application to. You can write data into it using the same commands that you would use if you were going directly into S3, but you don't have to go over the WAN to do it. So it's a way to front load that data and make it transparent to the application. We do have an NFS interface using our file gateway on the Snowball Edge, so you can write data through the S3 API. You can also write data through the NFS interface. You can cluster multiple devices together, keep them in the data center for an extended period of time, cluster them together so that you get some fault tolerance, some higher availability, as well as much higher capacities. So if you need that type of storage, if you want to keep an S3 style storage inside of your own data center for an extended period of time, you can do that with Snowball Edge. And of course, to be able to process the data, we're doing that in Lambda. So you can load Lambda functions directly onto the Snowball Edge so that as data is written, it's getting pre-processed, tagged, converted, maybe creating thumbnails for JPEGs. You can do all the things natively inside Snowball Edge without having to wait until that data gets uploaded into a bucket and then transferring it later. So the process to use Snowball and Snowball Edge, you log into your console, you create a job. This is where I need to ship it to. This is the S3 bucket that I want the data written into. So when you use Snowball or Snowball Edge, the data that you write to it is going to be moved into the S3 bucket that you specify when you create the job. So you pick the location for the data once it lands inside of AWS. We ship you the Snowball, you connect it, you fill it with data, you turn it back off, hand it to the delivery driver, they bring it back to AWS. At that point, we verify it physically and electronically that it hasn't been tampered with. Provided it passes all the checks, we plug it into the network, we copy the data into the bucket, and you get an SNS notification back that says all the data is successfully in the bucket, and then you can start processing and using the data just like you had moved it directly into S3 over the API, over the network. So short customer example of someone that's doing this today, Oregon State University. They are using Snowball Edge. They're sending it out on a research vessel. So it gets put on a ship, it goes out to sea. They're doing research, they're collecting data, they're writing it to the Snowball Edge. They are pre-processing the data, so they're pre-sorting, they're tagging, they're moving data into different groups, they're classifying, so that when it lands in S3 a few days later after the ship returns to port, all of that data is available for the researchers and it's ready to go. They can start using it without having to go through and do the processing stage. In the past, they would use USB hard drives. So you put a bunch of hard drives on the ship, you send it out, they fill the drives up, they get back. Now you have to pack them up, you have to get them back to the university, you have to connect them to a computer, you have to load them. Then you can start to think about how do we process and sort the data so the right researcher gets the right data set. And it took a very long time. So we're able to reduce weeks or months down to days by using the Snowball Edge. And we're not going to talk a lot about Snowmobile. It's 100 petabytes, comes in a tractor trailer and a container, comes with a guard. You plug it into your network, you can write 100 petabytes of data into it. But I love this slide. If anybody was at the keynote today, our friends from Digital Globe were there and they were talking about what they're doing. They're a public customer of Snowmobile. And inside the yellow oval there is a picture of the Snowmobile at their facility in Colorado when they were filling it with data. And they took the picture by flying one of their satellites over their headquarters. So that's what a Snowmobile looks like from space. And if you want more information on what they're doing, there is a URL at the bottom there. They wrote an excellent blog post, and that's where I got the picture from, where they explain the process that they went through, why they use the Snowmobile, and what the data that they're moving with it. So the last slide on the Snow Family, and we will take questions at the end. Some of the use cases where we see customers using Snowball, Snowball Edge, and even Snowmobile. Certainly cloud migration. I'm migrating data into the cloud. this is what it was built for. I have a bunch of data in the data center. It's too much to send over the network. If you do the math on how long it can take to move tens or hundreds of terabytes over even just a 1 gig link, we can do it in days versus months or years. So I'm going to migrate data in. Maybe I've been putting data in. I've been doing backups, or I've been doing snapshots up into AWS, or processing data, and I have a disaster, and I need to get that data back out. Snowball is a way to do that. You can create the job, tell us the bucket and the data that you want loaded onto the Snowball. We will do it and ship it to you. And you plug it into your local network, and you can copy the data back over. Data center decommissioning. This looks a lot like a cloud migration, but it's something that's becoming more and more common. This isn't I have a subset of data that I want to put into AWS and I want to make it available. This is I want to turn the lights out on that data center, and I want to get all of that data and all of those machines up into AWS. This is a way to be able to do a bulk data move. And then finally, similar to what Oregon State University is doing, is the remote data collection. So if you think about the oil and gas industry, where it's not necessarily a friendly site where you're going to be collecting data if it's out at an oil field or out at a mine. This is a way to go out there with a rugged device, collect data where there is limited or no bandwidth, and to be able to get it back into S3 in the native format to take advantage of it and use it. The next thing we're going to talk about is S3 transfer acceleration. And transfer acceleration helps to solve a fairly difficult problem. And that is, if I have the bandwidth, but I'm far away from where I want to put the data, what do I do about it? And the issue here is latency. Latency, packet loss, if you're going over the internet, as little as 1/10 of 1% packet loss with 80 milliseconds of latency can reduce any single TCP stream to somewhere between 4 and 7 megabits per second. Notice I didn't talk about how much bandwidth you have. So this is a common conversation. In this case, we're in India. We're connected to US East 1 in the picture. I could have 100 gigabits of bandwidth, but with the latency on that link and any packet loss or out of order, it's going to reduce the throughput of my copy operation to somewhere in the neighborhood of 4 to 7 megabits per second. It's just a function of TCP, send, receive windows, retransmits, slow starts, all of those things that you don't think about, but that combine together to reduce performance. So with transfer acceleration, we offer you a way to get access to an S3 bucket in a region that is potentially thousands of miles away, and to do it like you're sitting right next to it. And we're doing this with the Amazon network. So if you're familiar with our content delivery network, our CDN, this is essentially a CDN in reverse. So instead of being an end user and connecting and streaming something from Netflix and going from that local POP, so I'm getting high performance, I'm actually going to put data in, and I'm going to do it by connecting to an AWS Edge location. There we go. And then I'm going to use the Amazon network to be able to travel over. Because once I'm on the Amazon network and I've connected to the Edge location, we can control the TCP window size, we can control the bandwidth. There is no packet loss on our network. We can make sure that out of orders are kept to a minimum. So we can give you the maximum amount of bandwidth available between your connection and the Edge location, and then optimize everything as it goes back up into S3. It's pretty easy to get started doing this. You tick a box in the console to say enable transfer acceleration, and then you add S3-accelerate after the bucket name. And that's it. You don't have to change anything else. As soon as you do that, Route 53 is going to find the closest AWS Edge location or Amazon Edge location. You're going to connect to it, and it's going to optimize from there. What this looks like in the real world is somewhere around 171% improvement on average. So because latency is a factor, you can see that on the far right of this graph, if we start in Singapore and we're connecting to an Edge location in Singapore, we're not going to make it any faster because there's nothing to optimize for. You have extremely low latency already, likely measured in single-digit milliseconds. But as we start to get farther out and farther away from Singapore, so into Tokyo and Seattle, the improvement is a little bit. But as we get into Australia, the east coast of the United States, or even down into Rio in Brazil, now it's a very marked improvement. We're more than 100% faster to be able to move data into that S3 bucket. So if you have end users or partners or someone that's loading data into your bucket, and they are geographically far away from where that bucket is, which region it's in, transfer acceleration is a way that you can improve the performance and do it without having to make any major changes to the application or the way the application behaves. You just change the URL. Huddle is a fantastic use case. They're a customer of ours. They collect game film. So, the iPhones or iPads or cameras that are out, say a Friday in the United States, a Friday afternoon or Friday evening when high school football games and college football games are happening. You can be out there collecting video and having the coaches collect video. It gets uploaded through the Huddle application. They process it, and then they give it back to the coach in an app that he can use to show the players. You did this when you should have done that. Or the next time you play these guys, remember this. So it's a way to go and look at game film and to be able to aggregate all of that so that they can then reuse it in near real time. And what I thought was interesting, and I had to read this one several times to wrap my head around it. On a typical Friday during football season, American football, for every minute, they're storing 35 hours of video. So between 5 p.m. and 5:01 p.m., they store 35 hours worth of video. And it's because there are hundreds of games, potentially thousands of games being played at the same time. You could have 10, 15, 20 cameras on iPhones or iPads all running at the same time, collecting multiple angles. All of that data gets processed back up into AWS. It gets transferred, it gets processed, it gets transcoded, it gets tagged, and then it's made available in their application. With transfer acceleration, they're getting greater than 20% increase, and not only throughput, but also to when they can start doing their encoding. Because the faster the data gets into the system, the faster that they can start encoding it, the faster that they can make it available to their customers. So just by getting the data there faster and more efficiently, you get to a result much, much more quickly. So the next thing that we're going to talk about is Storage Gateway. And Storage Gateway is a way that you can connect your data center to AWS using native protocols that your applications already support. So we offer a file version, a volume version, and a tape version, and we'll talk about these all in more detail. But a few key ideas that are shared amongst the three different modes of the file of the Storage Gateway. They all take advantage of AWS storage on the back end. Data stored in S3. For the tape gateway, you have the option of putting data into Glacier. For the volume gateway, you can take EBS snapshots. So they're using the tools and the infrastructure inside of AWS that you're already using today, and things like CloudWatch and CloudTrail for monitoring and management and logging work with all the storage gateway modes. Things like IAM, key management. The things that you're doing today wrap around the storage gateway product and make it available on premises. So in this case, we can have a storage gateway deployed, and we're in Southern Oregon. We're running iSCSI, so we're connecting to a volume, we're mounting it, we're writing data. One of the really cool things about Storage Gateway is with the volume and tape, it's going to store the data in the region that it's activated in. Doesn't make a difference where you actually physically deploy the virtual appliance and start writing data to it. In this case, that's Southern Oregon. We're activated in US East 1. So that means you have to go to the console for US East 1 to be able to see it and manage it. But that means that when it uploads data into the service, it's uploading to US East 1. You have a disaster recovery copy of the data that is geographically separated from your primary site as soon as it's uploaded into AWS. And you didn't have to do anything extra. You didn't have to do anything special. You just activate it to a separate region, and you get that automatically. So for the file gateway, this is the way that you can connect applications that are running in your data center today that don't support S3 to S3. So if you have an application that you bought from a third party, maybe even you developed it or had someone develop it, and they're not around anymore, and you want to start writing that data into S3, a lot of the times the answer is change the app. Instead of writing NFS or SMB, just have it write to the S3 API. But that's not always easy to do. And so File Gateway gives you an NFS interface to S3. Again, it's deployed as a virtual machine, the same as all of the other storage gateway models. You have some local cache so that you get high-performance writes, and if the data is in cache, you get high-performance reads. Using NFS version 3 or 4.1, the reason that that's important is 4.1 is great for Linux. Version 3 is supported by Windows. So if you're on Windows Server 2012 or Windows Server 16, Desktop 8 or Desktop 10, you'll actually get really solid, reasonable performance out of NFS version 3 with the current client that Microsoft has in Windows. So you have access to the Storage Gateway VM. Any data that you write to that virtual machine is going to get transferred up into S3. You can store it in S3 standard. You can store it in S3 in frequent access, so you have the choice up front. You can also use life cycles. So you can move that data down. When it's new, it goes to S3. When it ages out 60 or 90 days, you put it in S3 in frequent access because it's likely not going to be accessed as much. And then as it gets older, you can even move it into Glacier. But what's really interesting about the File Gateway is that we don't obfuscate the data in any way. So that means if I write word.doc to the File Gateway, I'm going to get word.doc as an object in S3 in the native format. So that means that you can use things like Athena or S3 Select now. You can query the data in place in real time, and you don't have to make any changes to anything. You just point the application at the File Gateway using NFS. The data shows up inside of the service. A couple of use cases for File Gateway. The first is the in-cloud workload. And we're seeing this very commonly with customers, where if you think about research environments or places where compute is heavily valued, and the more compute you have, the more CPU cores that you have, the faster you can get to a result. Well, in this case, we have customers that have instruments that only speak NFS. They bought them from someone else. It's hardware. They can't just change it to support S3. So using the File Gateway, they're able to take information out of those instruments, write it to the File Gateway, get it transferred up into S3. And this is where it gets really interesting. Because once the data is there, we have a notification service that you can call via API. We'll send out through an SNSQ that all the data is uploaded, the cache is clean, you can start working with it, and you can use that to trigger other events. So imagine you're writing a bunch of data into the bucket. You need to process it so that a researcher can get access to the data and start doing something with it. We write it, the notification goes out, triggers an event that then spins up tens of thousands of EC2 spot instances. So you're getting the lowest cost compute on demand at a scale that would be very difficult to match inside of your own data center. So maybe if you have 1,000 cores in your data center and you spin up 10,000 instances, you get to the result 10 times faster, and you get the data back 10 times faster. You call refresh cache. We make the data available back to the researcher through the File Gateway who's sitting in the data center or in the lab, and now he's able to continue on and do work. File sharing use cases. We're seeing this as something that's popular in the media and entertainment space. So it could be that I am writing multi-terabyte files. Maybe it's 4K raw or 4K encoded video, and I'm writing it up into an S3 bucket. Maybe it's a new movie that's coming out. And I want to make it available to every geography where it's going to be coming out, so they can cut their own trailer, or they can get the right language in, or maybe they're going to get access to resources to make posters that they're going to use in theaters. This is the way to upload the data once through the File Gateway and have a File Gateway image running, a virtual machine running in each of those remote sites, and they can get access to that data through a read-only share. So there's one single master copy of data. And as an end user in a remote site, I can connect to it, pull down what I need, and just have that data available and use it locally. And then the last one, And this is one of my favorite use cases, Snowball and Storage Gateway together. It could be that I've got a petabyte of data in my data center, and I want to put it up into S3. But once it's in S3, I still want to take advantage of being able to read and write to that data set inside of my data center. But I don't want to copy it over my WAN. So in this case, you order snowballs, you fill them up with data, ship them back, the data goes into an S3 bucket, the file gateway is connected to that same S3 bucket. So you can have 10 buckets connected to a single file gateway. Each bucket will be represented by a separate NFS export. So now I've moved all my data from my data center into S3. I have a file gateway. I can still access the same data as if it were local, but I don't have to maintain storage in my data center anymore. Everything is done up in S3, and I'm paying pennies per gigabyte, and I get the 11 nines of durability and all the things that are around S3. So Moderna is one of our customers in the biotech space that's actually doing something very similar to what I described with the instruments, where they're collecting research data, they're writing it to the file gateway. The instruments that they're using support NFS. So all of that data goes to the file gateway, it gets uploaded into S3, and then they can process it there at a scale that is much more difficult for them to be able to do inside of their own facility. We also have partners like SAP that are using File Gateway as part of their solution set to be able to provide backup for things like Adaptive Server Enterprise. So in this case, you have ASE, Adaptive Server Enterprise, running in your data center. You have a backup server. You're mounting those adaptive servers. They're exporting their database or exporting log files or replays. You're writing that data into the File Gateway virtual machine. It's getting transferred up into S3. And this is where we're using an upload notification to trigger a CloudWatch event to tell you that all of the data has been uploaded. So now you know I started a backup at 5 p.m. and by 6 p.m. all the data was written to the gateway because it's a 5 terabyte database, and it was also transferred up into S3. So now I know that I have a good copy as of 7 p.m. The backup from 5 p.m. is completely finished and it's being stored inside of AWS. You can also do some other fun things with the CloudWatch events. You can use them to trigger refresh cache. You can also use them to trigger Lambda functions. So there's a lot of flexibility that you have in that type of environment to be able to trigger and process data in different ways and to do it automatically. The reason that I say that Snowball and File Gateway together is one of my favorite use cases. So Halliburton Landmark Services moved hundreds of terabytes of data off of LTO as an archive solution. So it was on a filer. They would move it off to LTO. They would send the LTO tapes out in a locked box to be stored for long periods of time until one of their customers would say, hey, we need that data back. We're ready to process it. We're going to use it. We're going to do something with it. They would call, open a ticket, wait for the tape to come back, unlock the box, load it into the library, re-index it, put the tapes into slots, go to the backup software, start the process. And that was days or weeks from the time that the customer said, I want my data back, until the time that they could say, okay, all of your data is back online, you can start processing it and working with it now. It's kind of a painful process. Using Snowball, they were able to copy all the data off of those LTO tapes back through their filer, transfer it up into S3, deploy a storage gateway as a file gateway, and give access back to that data inside of their own data center. And by doing that, they were able to take the time to data for their customers from days to weeks to minutes. And now it's a self-service operation. So their customers no longer have to pick up the phone or open a ticket and say, I want access to my data set. Can you bring it back so that I can start using it? Now the customers just go in and the data is there and they can start using it on their own. So they're able to greatly simplify the process. One of the things that I think is amazing is they reduced the cost of archiving and storing this data for long periods of time by 90%. 9-0. And we were on the phone with them talking about this. I think that we probably asked them 3 or 4 times if we were hearing the right number, because it's a pretty dramatic reduction in how much it costs to store that data and archive data for long periods of time. So next up, we'll talk about Volume Gateway. Our Volume Gateway presents an iSCSI LUN or volume to a server inside of your data center that you can mount, write a file system onto, and then store all of that data up inside of AWS, inside of S3, using the Storage Gateway service, where we store the data compressed and encrypted before it even leaves the Storage Gateway virtual appliance. So unlike the file gateway, where we leave it in the native format and we don't change it, with the volume gateway and the tape gateway, we compress, encrypt, and then transfer it up into the service. Using volume gateway, two different modes that you can store data: cached volume mode and stored volume mode. With stored volume mode, if you have 10 terabytes of data, you need 10 terabytes of disk capacity available to that virtual machine, because we are going to keep 100% of the data in the virtual machine as well as in the service. So that means that reads and writes are all going to happen locally over iSCSI to the Storage Gateway virtual appliance, and it's going to be making copies of that data, sending it back up into the service, storing it in S3, where you can then take snapshots or make clones of that data. And when you take a snapshot, we use the AWS Snapshot service, which means that you can have data from a server inside of your data center, take a snapshot up into AWS, convert that snapshot to an EBS volume, mount it to an EC2 instance, and do processing inside of AWS. It also means that you can just migrate all of that data and someday even move the application up. One of the other cool things about stored volume mode is that you probably have a SAN, maybe you have an iSCSI SAN in your data center today. You have a bunch of LUNs provisioned, they have file systems on them, disk signatures, data, you're actively using them. You can take that LUN, present it to the storage gateway, and we will pass it through back to the original initiator and change nothing, which means that it's data in place. The signature doesn't change, the file system doesn't change. The application server will continue to run with the data that it's always had. But now you have a copy of that data up inside of S3, because we're going to start copying it block by block into S3, and you can take snapshots of that data inside of AWS. So you just migrated data that was on premises in a LUN into AWS, and you didn't change anything from the application other than putting Storage Gateway as a bump in the wire. We also have cached volume mode. Cached volume mode means that we have disk cache that is not equal to the size of the LUN, and reads and writes are going to happen from the cache. So if you have a 10 terabyte LUN, you have 1 terabyte of cache. 1 terabyte of the most recently used blocks are going to be resident in the cache. New writes are going to happen to the cache. Reads are going to happen from the cache if the data is in cache. If not, we'll pull it down from the service, store it in the cache, and then service the read. Again, you can take snapshots, you can create clones. It's integrated with all of the other tools with EBS snapshots. Functionally, from a management standpoint, the two different modes are the same. The only difference is one is a 100% copy of the data in your data center, and the other is not. It's a subset. Some of the interesting things that we have customers doing with Volume Gateway is to solve the Windows storage problem. Everybody has a Windows storage problem if you have Windows clients. There's lots of smiling faces and laughing that I can see even with the lights on. And it's because end users generate data. We email it to each other and we store new copies of it, so you have the same file 500 times and it's labeled, I know our presentations for reInvent are labeled Tuesday Final, Tuesday Final 2, Tuesday Final 3, Tuesday Final 4 ED, because I'm the one that edited that one. So you end up with these multiple copies, and we keep them all around because we're not good at deleting things. And it could be that I edited a version and then decide that, oh, the one 3 versions ago was actually better, I need to go get it back. So we keep everything. And in a Windows environment, that becomes difficult to manage because you've got to back it up, you've got to provide storage for it, it just keeps growing because we don't delete anything. And so we have customers that are using the Volume Gateway behind a Windows server so that now they've got essentially bottomless storage that they can present to this Windows server, and inside their data center, maybe it's using 500 gigs or a terabyte of cache, and that's the only physical disk space that you have to maintain in the data center. Everything else is stored in the service inside of AWS in S3, and you get the durability of S3, you get the snapshots for backup or for being able to do disaster recovery and recover that data. So it's a great way to solve that problem. So we built this, and we have these ideas of what customers are going to do with it. But in my just under 2 years at AWS, one of the things that I've learned is that we've got really smart people at AWS. So we build something and we give it to our customers, and our customers come up with things to do with it that we never thought of. And so this started, we've got a lot of customers that are doing this now. The first time that I saw a customer do what's on the slide, I got a call from one of our SAs and one of our technical account managers, and they said, hey, my customer wants to do this thing. Do you think it will work? They sent me the Visios, and I sent them to the service team, and we sent them to the engineering team, and we all got together and looked at it and went, should work. We hadn't thought of it. What the customer was trying to solve for is, how do I reduce my storage footprint for Windows in my data center and make it highly available and fault tolerant so that if any individual piece goes down, my end users and applications will have no idea. So they deployed a pair of Storage Gateway virtual machines in cached volume mode, a pair of Windows servers with DFS, distributed file services. So now I've got 2 copies of the data, 1 on each storage gateway. By the way, I'm paying 2.3 cents a gig for each copy. So I'm up to 4.6 cents per gig for fully redundant copies of my data. The end users and the applications connect through SMB. And one of the things that we've learned is customers keep telling us we want SMB. We want it for EFS, we want it for file gateway. I have an SMB problem. And when you say SMB, one of the things that gets lost is that it really means that you want Active Directory support, you want NTFS permissions, you want ACLs, you want header and compression encryption, you want SMB direct, you want all of the other things that are wrapped around SMB. And there's really one place to get all of those things that works well, and that's out of a Windows server. So using Windows and DFS and Volume Gateway, they have this highly available fault-tolerant environment. And what they figured out through testing and an actual event is that they can fail over from one to the other in single-digit milliseconds, and end users and applications have no idea that anything went wrong. They're taking snapshots of one of those volumes up into EBS, so that's the disaster recovery copy, and then there's a business continuance copy that's happening into a different region. So you can see here, our primary is in US West 1, our secondary is in US East 1, and they have a Windows server and a volume gateway running inside of EC2 in US East 1, and they're using DFSR, which is asynchronous replication, to keep a third copy of the data. We're now up to 6.9 cents per gig for the first 49 terabytes, with 3 independent copies of the data stored in 2 different data centers on 2 different coasts. And the reason that I make a point of that is when you only look at it and say, I'm storing 3 copies of my data, I challenge you to find any other way to keep 3 copies of your data in 2 separate data centers for less than 7 cents a gig. It's not something that's really easy to do, but this is a way to deploy it with no downtime, get HA, get fault tolerance, get a disaster recovery copy, get backup copies through snapshots, and have all of it available in a way that your end users and your applications have no idea that anything changed. There we go. Candy Crush. Do we all know Candy Crush? I always have to mention Candy Crush because I know a lot of times this slide comes up and not everybody knows who makes Candy Crush. So King is a big AWS customer. They make Candy Crush and a whole bunch of other games. They're using the storage gateway in volume mode to provision storage inside of their data centers around the world where they have physical locations and people very quickly. And they had the challenge of someone would come in and say, I need 500 terabytes of storage and I need it tomorrow. And that can be very difficult to solve if you don't have more than 500 terabytes of free disk capacity sitting around inside of your data center. And so the volume gateway is a way for them to be able to address that requirement and those needs from their users in a matter of minutes by provisioning a new LUN, giving it to the server, and then that user has that amount of capacity. And you can certainly use this for backup and disaster recovery. Having a copy of that data inside of AWS, being able to take snapshots that are in an EBS format, you can then reuse those snapshots, connecting it to an EC2 instance that you spin up inside of the cloud. You can also give it to another volume gateway maybe in a different region or in a different data center, so that you can recover that way as well. So it's a very fast way to get a complete copy of that data someplace else that's read and writable. You can also create clones. So a clone is a copy of the data that's going to live inside of S3. You give it to another gateway. So when you go to create a new volume, you have the option of creating from a clone. And when you do that, it's instantly available, and it's going to be a separate copy of the data when we're done making a copy of it. But you can use it right away. So reads are going to come from the authoritative source. Writes are going to go into the new volume. This is a great way to do development, because your developers typically want the data in its most current format. They don't want 6 months ago's data. They want the data as it exists right now, because we're going to try something new and we want to know what's going to happen. You create a clone, give it to the development environment, and they have the data that is current as of the time that the clone was created. And it has no impact on the production environment at all. We make a separate copy of the data, present it up as a volume, and they can work with it instantly. So the last storage gateway mode that we'll talk about is tape gateway. Pretty self-explanatory. Presents a virtual tape library. We give you 10 drives, a robot, 1,500 slots, and you can create a tape up to 2.5 terabytes in size. That means you get 1 petabyte of capacity inside of that library, represented by as little as 100 gigabytes of disk cache. So this is a cached virtual machine. By the way, I actually have a science project that I created, where I created 32 terabyte LUNs, which is 1 petabyte, presented them all to the same server, put them in a storage pool, formatted it as a single volume, and I have 1 petabyte of addressable capacity. I haven't written a single byte to it, but I have a 1 petabyte LUN. And I did it with 100 gigabytes of disk space, physical disk space in the cache. I don't recommend you try this at home for a production environment. It's fun to do for sort of a science experiment, but 100 petabyte or 1 petabyte of capacity represented by 100 gigabytes of disk cache is not going to be a good experience when you start to write data to that petabyte. But it works. It's there. So you want to size the cache appropriately. So with tape, you have your disk cache. All of the data is going to be stored back in the service inside of S3. You have the local cache so that you get a high-performance write. I think the voice is about to start going, so I don't know who had 17 minutes left to go, but you won the bet. Excuse me. You have the local cache, so you get the high-performance writes. If the data is still in cache, you get high-performance reads. All that data gets moved into S3. If a tape is in one of the 1,500 slots or in one of the tape drives, that means the data is being stored in S3. Similar to a workflow that you would have inside of your data center with a physical device, you can export tapes out of the library. When you do that, we make a copy of that tape into Glacier, and we mark it as read-only. That's your archive workflow. That is the tape that you are now putting in a box and putting it on a truck and sending it away and hoping that you never need to read the data again. And if you do, you're hoping that the tape actually works and that the data is readable. Now you can do that all inside the same workflow, maintain the same policies that you're using today for backup inside of your own data center, and shift that workflow into S3 and into Glacier, just by changing the destination. Instead of going to a physical library, go into the Storage Gateway VTL. With some of our partners, Veeam is a fantastic example of this. You're doing your backup to disk, you're creating an archive clone into the tape library and putting that data in Glacier. So you get the high performance local, you get the long-term storage at 0.7 of a cent per gig as the data sits inside of Glacier. A great use case, Southern Oregon University. I don't know if anybody was in the session, I think yesterday, when they spoke. They're actually the example that I used earlier when I said, hey, Storage Gateway writes the data to the region where it was activated. So they're in Southern Oregon, they're using Veeam, they're backing their data up, they're creating an archive copy into the Storage Gateway VTL that's been activated to the east coast of the US. So that means as soon as they build their archive copy, they also have a disaster recovery copy that they can use to recover inside of EC2. And they didn't have to do anything special. It gets uploaded, it goes to the other coast. So they don't have to maintain that separate data center. And the last thing that we'll talk about is EFS file sync, and then we'll go to questions. EFS file sync launched last week. And this gives you the ability to do high-performance data copies from an NFS export into an EFS file system. You can also use it to go from EFS to EFS if you have that requirement. But you deploy a virtual machine inside of your data center, you create a new batch job, and then what you mount, whether it's a subdirectory of an NFS export, the root level of an NFS export, we will go through and copy all of that data through our service and store it in an EFS file system. So it's a way to very quickly migrate data from an NFS file system on premises into AWS, put it into an EFS file system, and have it available. We also have some new storage training that's been available or made available. So you can see www.aws.training. New things that are available, new certifications or accreditation program that's available. You can go in and get deep dive training, get high-level overview training on all of the storage services that we have available at AWS. And so with that, thank you for coming. And now we'll do questions. And we've got so we have a microphone in the back, and Dylan has T-shirts, one of which I am modeling. For the first 3 people that ask a good question. Oh yeah, there you go. That's the back of the shirt. There's one up here in the front, Dylan. I think you're next.
Okay, thank you. It was a great presentation. I guess just could you elaborate more on what you do for applications where you need a really fast failover? Let's say you need sub 1 second failover. It's just still not clear to me how I could really use AWS for massive amounts of data and still keep my failover rates low.
I think it depends on how you need to connect that application. So if you're going over NFS or if you're going over iSCSI to the volume gateway, there are a couple of different architectures that you can deploy that will give you fault tolerance, high availability, with not only multiple copies of the data, but multiple gateways so that you're protected in different places. So say single application server where you want that HA and that fault tolerance, you can deploy a pair of storage gateway virtual machines, create the same size LUN on each, present it to that server, and you can do, say, RAID 1 at the OS level. So now you're getting, probably sub-millisecond failover time between the 2 volumes. At the worst, it would be single-digit milliseconds, should there be a failure at any single piece. And then when you start to look at doing files or doing multiple application servers, the architecture can scale out, and there are multiple things that we can do. I don't know that we have enough time to dive deep into it right now, but we'll be around at the end of the session if you want to go deeper on that. Yeah.
Hi, a good presentation. Quick question for a very simple use case where it's like 2 terabytes to 10 terabyte of data to be moved from on-prem Unix server to S3 buckets. What's like the best way to do that process?
So 2 questions would be, how much bandwidth do you have and how quickly do you want the data to get there? So if you're coming from an on-prem Unix server and bandwidth is a limitation, you've got 10 terabytes, less than a gig of data, or less than a gig of bandwidth, you'd probably want to look at Snowball, because that's a way that you can do a quick copy inside the data center, ship it back, and a few days later the data shows up in S3. If you have a longer period of time, you can use File Gateway and just mount an NFS export of that S3 bucket, make a copy of the data into the File Gateway, and it will all get uploaded to S3. And then you can even leave the File Gateway in place so you can read the data back out. And you can certainly do what Halliburton Landmark did, where you copy it in with a Snowball and read it back out with File Gateway. And did you have a question here too?
Yes. Sorry, I'm not really that familiar with the tape gateway too much. Could you explain kind of how you would read back and forth from the tape gateway? I mean, I have no idea about why people would use tape anyways.
There's still a lot of, tape is like mainframe. For my entire career, people have been telling me it's dead, and both are stronger than ever, as far as I can tell. And this is the part of the session that's not being recorded, so I can attempt to be funny. So with tape, when you write the data to it, it's going to go into the local cache. So you're going to want to size the cache large enough that you can hold the backup, or that you have enough bandwidth and the right amount of cache that you can stream the data in and then start streaming it into the service and not fill up the cache too quickly and overrun it and still have more data to write. So if it holds, let's say you have a 1 terabyte backup and you have 2 terabytes of cache. So you've got 2 days of backup inside the local cache. When you go to do the next backup, we're going to start pushing old data out. So we won't evict data from cache unless it's marked clean. Clean means that it's up inside of the service and we know that it's there. It's been verified with an MD5, so we write a hash every time we write something in. If the MD5 doesn't match, it's not going to get put in the service. So it shows up, we get the notification back. Now it's marked clean, we can purge it out of the cache. So you do the backup into cache, data gets copied up into the service. Now say you need to read data that is no longer in cache because it's a backup that was done 2 months ago. When you go to do that read for that tape, maybe it's in Glacier, you put it back into S3 into a slot, you start to read it. When the backup software is reading and streaming the data, we'll be streaming the data out of S3 back into the local gateway, into the cache, and then we're going to service the I/O out of cache.
Thanks. Good presentation. I might have missed this. I just wanted to ask, as the file gateway to the cloud, is there any compression or anything you do between that for efficiency?
There's no compression. So for file gateway, no compression. For volume and tape, we do compress. All of it gets encrypted. So with the tape and volume, it's compressed, it's encrypted, then it's transferred over an encrypted link. With file, we keep everything in the native format. And that's because we want it to be available to other services like EMR and Athena and S3 Select. And if we were to compress it or dedupe it or make any changes to it, it potentially would be unreadable by some of those services. And Athena can read compressed data. There are other services that can't work with compressed data, so we leave everything in the native format. Now, it is encrypted as it's being transferred over the network. So whether it's going over a DX or it's going over a WAN, an internet link, it gets encrypted in transit, and then we use SSE S3 to encrypt the data at rest on disk.
Excuse me. In your diagram, the volume gateway, was it a primary store or a secondary?
So we have customers that do both. We have some customers that are using the volume gateway as their primary storage. Just Giving is a public reference. We've got a case study of them on the website. They're doing OLTP and OLAP. They're out of the UK. They process payments and transactions for charities. And so it's highly transactional, lots of small things. And they're using stored volume mode. So they've got a full copy of the data. And that is their primary storage system for that. And then they're taking snapshots up into the EBS snapshot service with Storage Gateway.
I'm sorry. Hello?
Yep, you're on.
So in the case where they use it as primary, are you saying they keep in the cache the entire data? Because I'm thinking there may be otherwise latency to bring it.
For them, yes, because they are doing it in stored volume mode, so 100% of the data is kept in disk at all times. We have customers that use cached volume mode as primary, and you have to look at the size of the data and how it's used. So if you have 1 terabyte of data, but you only use 10% on average on a daily basis, you can have 100 gigs of cache or 150 gigs of cache, and to be able to effectively service those reads and writes 90% of the time. One of our customers, Stem Cell, they measure at 80%. As long as they're getting 80% cache hit rates on reads, they know that their cache is big enough. If they're not getting 80%, they increase the cache size. So you can manage it, and we give you all of those metrics inside of CloudWatch. You can see things like latencies, what you're reading, what you're writing, what the how the cache is doing, cache hits, cache misses, all of that's available.
Thanks for the presentation. We have a direct connect from our on-premise to AWS, and we would like to use EFS from our on-premise Windows server.
Okay.
do we still need a gateway, or we can directly connect?
So EFS over Direct Connect exists today. However, it's only NFS version 4. Windows Server is not compatible with NFS version 4. They only have an NFS version 3 client. So today, you cannot connect a Windows Server to EFS directly. No Windows clients can access that. Only NFS version 4 support.
Okay.
Unfortunately. So with
we can do
the
that,
file gateway, that's an interface to S3, and that supports NFS version 3 and 4, which means that we can support Windows and Unix, Linux.
Okay, but let's say we still have to use EFS. Do we then use, for Windows, do we still use like a gateway, or?
You can't.
You can?
No, today there's no way to connect Windows to EFS.
Okay.
The protocol just isn't supported, and we don't make a gateway to sit in the middle of that.
Okay, all right, thanks.
Sure. Any other questions? Oh, one more.
In the presentation where it's like in volume mode, how is that presented to the server itself? Does it show up as just sort of a big dumb disk or a LUN or something?
It's a nice fuzzy LUN.
Okay.
So if you, in the case of the science experiment that I mentioned earlier, I just started creating 32 terabyte LUNs, and I made 32 of them. And it takes a long time to make 32 terabyte LUNs one at a time. I've since realized that I can do it through Boto 3 and Python, and it would have gone that fast. Instead, I took like 45 minutes to do it by hand. Mount them all to the Windows server, and you get 32 LUNs. Go in, initialize every disk, write the file system to it, put it into a pool, and you're done. So it just shows up as a nice SCSI volume.
Okay, thanks.
Sure.
Incidentally, we're actually going to be doing a demo of the volume gateway at 5:15 in the day one theater of the expo, showing how you can take snaps and use them for application data migration into EC2, taking snaps, mounting them, et cetera. So it's like a 15-minute demo.
One right here,
5:15.
And any Doctor Who fans left in the... I have Storage Gateway TARDIS stickers in the back if you're a Doctor Who fan, because the Storage Gateway, like the TARDIS, is bigger on the inside.
So I don't know too much about Storage Gateway, but one of the problem spaces that we're looking at is exporting data back. So I read somewhere that you can export data up to S3, and S3 could be synchronized to your local, I guess through Storage Gateway to one of the volumes. How would that work, and what's the best practice on doing that?
So it depends on how you want to get the data back. If it's, I want to get the data out of AWS completely, then that can be a Snowball use case, where we'll copy the data to the Snowball, ship it to you. And so that's a very fast process that doesn't have to go over the internet or go over the WAN. Yeah, so that's a few days. So for real time or near real time, that's where the file gateway fits. So the data that's in the S3 bucket, the file gateway is only aware of data that was written through it. So we have something called refresh cache, which is an API call. And you make the API call to refresh cache, and it tells the file gateway, it essentially goes and it does a head on the bucket, and it looks for things that are new, things that have changed. And the way that the index for the file system works is that we only keep in the index things that we're aware of. So if I have 100 subdirectories, S3 is flat, so there really isn't a subdirectory, but I have 100 prefixes. Each prefix gets represented as a subdirectory on the file gateway. So that's how we convert the flat object namespace into a file system namespace. So you have all those 100 directories. If you've never done an ls on a single directory or browsed through it through Explorer, then we're only going to know about the directory names. As soon as you go into one of the directories, then we look at that piece of the bucket, and we put that into the file system view. So when you call refresh cache, we will go and look at the things that we know about to see if there are new objects or new prefixes that we need to represent as directories and make that available. And that happens in the order of seconds.
Sorry, follow up on it. How do you do the resolution between, or conflict resolution between two systems?
So we don't support active writers between two file gateways in a single S3 bucket because we don't do any file locking at all on the file gateway side. And so We do have customers that have multiple writers. So we have a customer now that's moving in 1.6 petabytes of data through 6 file gateways. But they wrote their own chunking software. So they're chunking their data into 4 terabyte chunks, and each chunk goes to a separate file gateway, so there's no overlap. You know, if you're in an environment where you need multiple writers, then there are ways to do it, but you just have to be careful to make sure that Gateway A and Gateway B are never trying to write to the same object in the same directory at the same time, because we don't have conflict resolution for that. Sure, we've got, oh, I think I'm over time. I didn't realize it starts flashing red and counting up. I was like, we got 30, oh, 36, no, we're done. All right, thank you guys very much. And like I said, if you want stickers, we have them in the back.